Hi class, I'm Dr. Aristotle Obando from the Mechanical Engineering Department, and today we'll be discussing Introduction to Research. So let's get started. Hi class, welcome again for another lecture of our course Meremy. And for today's lecture, we would be discussing Introduction to Research. Let's take a look at the outline of this presentation. We'll start first on the research motivation. How do we now start research? Then we would go now to the definition of research and its purpose. Then next, we would be defining what a good research study is. Next, we would be classifying the various types of research and relate it to our field, which is mechanical engineering. In doing so, we would be defining the role of a mechanical engineer to its society. And lastly, I would just summarize our presentation. So let's start off with this picture or painting. Can anyone tell me what this painting is? In doing so, we would be relating art and research. So the painting that you just saw is called The Starry Night, which was painted by the Dutch painter named Vincent van Gogh back in 1889. And mainly, that view is his inspiration. It's the landscape that he is seeing on a daily basis. That's why he was able to come up with that very famous painting. Just like any artist, by drawing or painting his ideas or his art, research starts with an inspiration. And inspiration can be drawn from our experiences in our own daily lives. Let us now define inspiration. Inspiration is a process of being mentally stimulated to do or feel something, especially to do something creative. This is based from Google Dictionary. And based from this definition, there is somehow the keyword creative. There is a creative process happening from that inspiration. So, inspiration can result to a research problem statement. What this means is that from our daily experiences of our own lives, we are inspired in solving a specific problem or a specific topic which we want to somehow investigate in our research. So let's first define what is research. First, research is defined as a careful, critical, disciplined inquiry varying in technique and method according to the nature and conditions of the problem identified, directed towards the clarification or resolution of a problem. So first, from our experience, we need to define what specific problem we want to answer in our research. Then from there, we would apply critical thinking or systematic process on how to answer those questions. Another definition of research, it's simply the systematic search for pertinent information on a specific topic or problem. This is the most common definition of research. Sometimes we have a question and we want to somehow answer that question. We try to go to the internet or try to Google some of the ideas that we want to answer, or some of the problems that we want to answer. Another definition of research is that it can also be defined as a process of gathering data or information to solve a particular or specific problem in a scientific manner. So I think in considering all the definitions shown here, there is this scientific process or scientific manner in answering a specific problem. And by gathering data, by gathering information about that specific problem and documenting it, we now call that process research. Now let's now discuss the various types of purposes of research. First, research is done to discover new facts about a known phenomenon. Next, to find answers to problems which are only partially solved by existing methods and information. So if there are problems that not yet fully understood, then we may use research for us to answer those questions. Next, improve existing techniques and develop new instruments or products. I think as a mechanical engineer, this is applicable for us since we are used to solving problems, developing new ideas, or creating or fabricating a model or a prototype. We are then improving a specific process or invention by innovating and coming up with a new or improved design. Next, to discover previously unrecognized elements. I think this is more of applicable for chemical engineers or chemists. Also this one, to discover pathways of action of known substances and elements. So those are some of the purposes of research. Next, to provide basis for decision making in business, industry, education, government, and other undertakings. Perhaps with this purpose, we can use research for decision making purposes. If we want to somehow buy a certain car, we would like to gather more information about what type of model we would consider, what would be the mileage or fuel consumption. So those are the factors, and somehow compare the alternatives that we have during that time. So I guess by making a decision, we are also doing research for us to make the right decision. Next, and I think this is the most common for students, to satisfy the researcher's curiosity. Sometimes we are curious, we want to satisfy our curiosity by somehow answering those questions or finding ways for us to answer those questions. Sometimes we would go for some experimental approach or computational approach to answer those questions. Next, to find answers to queries by means of scientific methods. Next, to acquire a better and deeper understanding about one phenomenon that can be known and understood better. So there is this somehow search for deeper understanding of a specific topic. And if we try to read some books and try to look at the various literatures, we are not yet satisfied with the answer. And that's why we would like a deeper understanding. Sometimes we do some experimentation for us to further validate our hunches or hypotheses. Next, to expand or verify existing knowledge. So research is also done to verify information, to verify data, and for us to validate those data and our questions. Okay, let's now try to discuss what a good research is. What are the characteristics of a good research? So first, it has to be systematic. There is a research process for us to conduct a very good research. Next, it has to be controlled. So we have to know first and foremost what are the factors that we want to investigate and what are the responses that we want to somehow relate to the factors or the variables that we are investigating. Having known already the factors and responses, the independent and dependent variables, we are able to somehow simulate it in a controlled environment so that we would minimize any errors in our assumptions. Next, research is empirical. Sometimes it's trial and error. We would try this method, and after a while, we would know that it's somehow not working. So we would try again another method. So research is also empirical. Next, research is analytical. We have to apply analytical process or analytical approaches for us to be able to interpret the data that we have gathered from our research. So we need to somehow relate the data that we have gathered to the problems that we have identified initially, and be able to come up with a conclusion in our study. Another characteristics of a good research is it's objective, unbiased, and logical. Now, some of the students somehow gets very emotional on their research. Now, we have to be very objective. We should set aside our emotions and be very logical in interpreting the data. I know somehow we already have hunches on what would be the results of our research. We have to be logical and unbiased with the results. And we have to document all the results that we have. Next, research employs hypothesis. For us to be able to identify a problem statement, we have to somehow develop a hypothesis. A hypothesis is somehow a question that we pose our mind for us to investigate. So sometimes we start with a hypothesis and develop it to a full-blown problem statement. Next, research employs quantitative or statistical methods. Now, this is very applicable for engineering field, for specifically in our course, which is mechanical engineering, as we need to present somehow quantitative data to prove our point. If we want to prove that the efficiency of our system improves, then therefore we need to present specifically or compare the efficiency of the previous design to our proposed design. So by doing that, that is already a quantitative method. And sometimes it would be best to somehow justify our conclusion by applying statistical methods. Statistical method is another approach wherein we can say that the results is somehow valid given a specific confidence level or the standard deviation of our data. Next, research should be our original work. And for us to be able to secure that our work is original, we have to first go through a process which is what we call literature review. And I would be posting a specific video on that, how to conduct a thorough literature review for you to be able to do that specific chapter. And relating the original work to your literature review, in your literature review, you need to somehow document all the previous studies done on that specific topic. If you are able to conduct a good literature review, therefore we are now in the position to identify the research gaps. What has been done, what has not yet been done. Therefore, we now focus on the areas of research that we can proceed with. And for sure, if we are able to justify that those areas are not yet done, therefore our research is somehow original. Next, research is done by an expert. And that is why some of the students, this would be your first time to conduct research, we would be partnering you with a specific faculty in our department. And that faculty would guide you in your research process, in writing your thesis proposal, in defending your thesis proposal, in conducting all of the activities of your thesis, up to defending and writing your final manuscript. Next, research is accurate investigation, observation, and analysis of data. We already have mentioned a while ago that we can apply quantitative methods or statistical methods in conducting a very good research. And here, we have to define the methodology in how we would conduct our research. We have to even identify how do we now observe, what types of methods did we consider, what are the assumptions that we have considered in the study, and try to analyze our data objectively. Next, research needs patience. And I think as students, you need to focus on being patient in research. There are a lot of highs and lows in doing research. You're given almost a year to do your thesis, and definitely there would be challenges, and you have to be very patient in overcoming those challenges. Next, research requires an effort making capacity. I guess for this course or for your thesis, you would be grouping yourselves into perhaps a 5-member group, and it would require the full capacity of all of the members for you to be able to address all of the challenges of coming up with a full thesis or full research study. Let's now go to the classifications of research. First classification, historical. So we can actually dig up our literature review and be able to document all of the past research or past studies done on that specific field. Research needs to be descriptive, especially in defining your methods and describing your data and comparing it to the data of others. So we have to be very descriptive in your research. Next, research can be experimental. And for experimental methods, I would post a specific video for this. Just to give you an overview of experimental study, it's somehow something that you actually execute in your research. And most of the undergrad thesis is done by fabricating a model. So you would need to come up with your prototype or a physical model of your idea and be able to validate the performance of that prototype. So that is somehow an experimental approach. Another approach would be a computational modeling or simulation. And mainly for computational modeling and simulation, that would require a software. Of course, obviously, we would need a computer for us to simulate. And somehow we need to relate that to a physical model. However, most of the study is mainly focused on the development of the model and the conduct of the computer simulation. I would post a separate video discussing only this method, computational modeling and simulation. Lastly, we have software-based. And nowadays, with the advancement of technology, the development of softwares has already increased or has advanced. We already have different platforms like Windows or Apple or Android, and we can even develop applications or apps for the various types of platforms. And in knowing the various classifications of research, somehow we can combine the various types of research. So say for example, a research can be done by combining experimental and computational modeling. You would need computer modeling to somehow choose the best design for your prototype. So you can do computational modeling as your phase one, then your phase two would be an experimental study. Or the other way around, we can do the experimental first, then verify the results of your experimental results with your computational simulations. Or perhaps in coming up with a prototype, we can combine experimental and your software based approach. So coming up with an apparatus, you would need somehow a software to control that apparatus. Either way, you can combine the various types of research and be able to use that in your own thesis or in your own study. Let's now go to our field, which is mechanical engineering, and let's try to define first what is mechanical engineering. It is a branch of engineering concerned primarily with the industrial application of mechanics and with the production of tools, machinery, and their products. This is mainly the definition of Merriam-Webster, and we all know we would apply various concepts, mechanical engineering concepts such as machine design, power plant design, thermodynamics, refrigeration, so on and so forth. You have a lot of theories you have taken from your freshman year up to this point, and in doing your research, you need to apply those concepts in addressing a specific problem or your problem statement. Now, the role of mechanical engineers, perhaps in our society, is to provide solutions and improve the lifestyle by applying any of the mechanical engineering theories and concepts. So by applying thermodynamics, we are able to recommend an efficient way of, say, producing electricity, reducing carbon dioxide emissions, reducing the consumption of water, so on and so forth. However, the proposed inventions and ideas of mechanical engineers should consider the environmental impact. Nowadays, there's an increase of awareness in the impact to our environment. So any prototype or any ideas, we need to always consider how would this affect the environment. Would we have an increased CO2 emission, or would we have a higher water footprint, so on and so forth. So we have to be aware of the environmental impact of our research or our product. Now, I have listed here two specializations at De La Salle University. We have first mechatronics, then we have energy. Let's tackle first mechatronics. So mechatronics is a multidisciplinary field of science which involves a combination of mechanical engineering, electronics, computer engineering, systems engineering, and control engineering. And in coming up with this specific field, we can apply this in various fields such as manufacturing, automotive, aerospace, medical, and there's a lot more. Next, let's discuss energy as a field of specialization. Energy is a field of mechanical engineering focused in addressing the uncertainty of energy production in the future. And at De La Salle University, we have a couple of topics that we can discuss, or we can use energy to answer some of the problems in our country. First, sustainable transportation. There's a lot of questions on how we can improve the transportation in Metro Manila. So we can apply sustainable transportation to address some of those problems. Next, the design of polygeneration system. If you are familiar with cogeneration or trigeneration system, this is somehow an advanced system wherein we consider multiple energy streams in a specific system. By doing that, we are able to somehow reduce the environmental emission and increase the overall thermodynamic efficiency. Next is the application of energy systems modeling to contemporary problems in the country. Energy systems modeling is a computational approach for us to recommend to our government that this approach would best have the benefit of our country in terms of energy production. So we are also discussing this as a course in the graduate level in our department. And lastly, I think this is the most common for undergrad students. They would deal with various renewable energy alternatives. So they would come up with the prototypes such as picohydro or microhydro, or even come up with solar PV arrays as part of their research. Another type of renewable energy alternatives that you can pursue is somehow the design of wind farms or wind energy conversion system, or OTEC, or ocean thermal energy conversion system. So those are some of the topics that you can choose as your thesis topic under the energy specialization. Okay, so we are now at the summary of our presentation. We have found out that inspiration and motivation is essential in conducting research. Sometimes our inspiration lies in our own daily experiences. We find some specific problems that worthwhile to pursue as our thesis or our study. Next, in this presentation, we are able to define what is research, and we also have discussed the various purposes of research and its classification. Then, we went to defining the characteristics of a good research and try to relate that to our field, which is mechanical engineering. And we have found out that the role of mechanical engineers to our society is to provide innovations and ideas to improve our lifestyle while taking care of the environment. And lastly, we are encouraged as students, faculties, and researchers to publish our work, publish our research. If our research involves fabricating a prototype or developing a model, a physical model, we are also encouraged to file a patent for those ideas. With this presentation, again, thank you for listening. If you have any inquiries, please do email me or post it in our Canvas online class. If you like this video, please do like this video. Try to post some comments or even subscribe to this channel. Thank you guys, and I'll see you again